How about now? How about now? Testing. Looks like you got audio to me. Yeah. Everyone, 2020, you're muted. You're canceled. Welcome. I'm gonna jump right into this after I finish my coffee and make sure everybody's here. That was here. Takes a little while for people to get in. They got to do that stupid Twitch ad. Again, the reason that I stop and start the stream is so we have a nice, clean video to post. In case if you're watching this on YouTube, when I know I leave the chat open with fishies and work, whatever I'm doing all day with music. If you want to just join us for the day on Twitch and just hang out. Who knows what you get. I mean, sometimes we just randomly talk about stuff. Sometimes you'll see me coding on cloud native stuff. I call it cloud native co-working. But yeah, and we listen to yoga music and that Eastern kind of stuff. Nice and chill. And I these days I haven't been changing the playlist. I've been using the same one. I've been actually adding to it, so it's got more stuff in it. And I used to play a lot of jazz and stuff, but I really respond well to the kind of chill Eastern stuff. So that's what's going to be there. You're supposed to be on the help desk. I appreciate you like the stream up during the day. That's nice. Yeah. So yeah, I mean, if you have music that fits into the mix of stuff that we play during the day, let me know. We had a couple people submit some Spotify playlists of stuff, and I'll just throw it in there and we'll just evaluate it and see how it goes. I kind of like it to be, a variety, but not too crazy of a variety. Anyway, let's get going. We got a lot of stuff to cover. You haven't missed anything yet. So I'm not going to be putting markers in today. So today we are talking about, we've been talking about functions the last couple of days. And so let's just review. Let's review what we've covered so far. I have to do this kind of at the beginning of every day because I inevitably make changes very organically to the stuff we covered based on how well it went. And I've been doing that for 8 years. We talk about it and I tweak it. I talk about it and tweak it, not necessarily here, but so I want to draw your attention, if you haven't read it yet, to make sure you go back and watch day 14 again. It's much more organized. It has references to linear algebra, and it's cleaner. We talk about subroutines, methods, operations, and what they are. So that stuff is not. And then this is really great. This is thanks to, I want to say, who was it that gave us this? I should call you out on it. It was really useful, Sir John, I think. Found the actual link to the otherwise very expensive POSIX standard. If you go to this at github.com/ was it Sir John? Yeah. If you go to this at github.com/rdvxrob/boost, you can click on the POSIX links there and go get the document. It's a PDF. It's about 300 pages. And normally you have to pay crazy gobs of money for it. It's probably illegal for you to download it. I don't care. I think charging for an international standard is beyond immoral. So just go get it. And, so there you go. Day 15, we talked about that. State types, variables, constants, and scope. By the way, if the link is gone, talk to me. I have a copy of it, but I'm just providing a link. I think that's probably safest. So what do we have here? We talked about variables. We talked a lot about state. I don't want to waste if there's anyone watching. I don't care if there's anyone watching. I mean, if there's somebody from The Man who's going to attack me for sharing an international POSIX standard for scripting with the world for free, bring it on. Because no. All right. So here we go. Always wrap double quotes. Use foobar to disambiguate. Don't forget to check with shell check. We're talking about BC for calculations and stuff. And here we are on today. So please, the takeaway here is make sure you read the updates to the most recent day at my inner Schwartz. Both Aaron and Randall, see what I did there? There's only a very certain type of astute viewer also old, who's going to get that reference. Channeling my inner Schwartzes. Use the Schwartz. There's a third reference for all the old people out there. If you don't know who Randall Schwartz is, look him up. Aaron Schwartz and Randall Schwartz, both of which champion the cause of these kinds of things. Use the Schwartz, yeah. So I'm not Jewish, by the way. My last name's Milstein. I have lots of, I don't know what I'm saying. Okay, day 16, function and command communication. So let's actually jump right into that. I have been struggling with how to. This year I actually finally bit the bullet and did something I've been wanting to do for a long time, which means we started shell scripting by learning functions. And the reason we did that, was because commands on the command line are a form of a function or a procedure, an operation, an action, whatever you want to call it. And so it was natural to start with an explanation of commands. And what do commands look like when you put them in a file? Well, they're still commands, right? They just kind of have a different name now. Now they're called actions or functions or procedures. And we talked all about that yesterday and the day before. So, and then that left us kind of like, well, how do we talk about state and variables and stuff? And we did that yesterday. And if you haven't noticed, I did notice in the chat earlier, you guys were talking about things like you guys are hoping I'm going to cover $at and a bunch of other special variables. But we talked about variables and constants yesterday in a mathematical sense. But we haven't linked them all up. I've referred to return values. I referred to arguments and parameters a lot. And we're going to come back to that. We're going to hit that hard as a method of communicating between what ultimately are, effectively internal commands within your script. So, and I really love explaining this way to people because when let's just jump right in. So when you explain what a function is to someone, like, well, what is it? It's just a grouping. It's like you're writing a little script inside of a script. It's like scriptception, right? It's a little subroutine. If your command file is a routine, is a command, then the other part is just a little bit, and that's all it really is. And you can go all the way down as low as you want to go, or go all the way up as high as you want to go. It's all an encapsulation of actions that are named lots of different things depending on how you're using them, but they're ultimately actions that have inputs and that do things, and then they have outputs and return values. So we're going to talk about that. We're going to talk about that specifically with regard to making things talk to each other and what that means. So, and in order for us to understand that, it isn't fair to refer to this as a form of composition. I think if you broaden the definition of composition from, specifically one way to deal with object-oriented programming or whatever, I think that composition in general is how everything is done. I think our universe is composition. One thing is composed of another, all the way down to objects and actions. And I actually clarified that on day 15. I changed the name of that. So when it gets really down to it, it's all about objects and actions, and you're always dealing with stuff at a different layer, all the way up to the meta level, right? And so what does that mean? Why do you care? You're just writing a shell script. I just want to customize my shell scripts and have a really sweet, bash RC file. Fine, okay, but we can add some other things in as long as we go down at turtles all the way down, yeah. So we're going to talk today about calling. Like, what does it mean to call something, like on the phone? I actually use this is the signal. This is the hand signal for a 1980s phone. See, I'm holding the. Let's see. What's the update of that? So if you're calling something on the phone, so you have to hold your hand like this in today's world, right? To indicate that you're talking on a phone. Or if you're in the early 2000s, you're okay, I'm on the phone now. I flipped my phone. So calling, what is calling about? Now you'll never forget the word calling now because I did all that crazy stuff. That's a mnemonic device. See? All right. So arguments passed by shell parameters, special shell parameters. the shell functions they only return integers. Exit, what is that about? Interprocess communication, which some people are going to look at that and go, why are you talking about IPC to absolute beginners? I say, well, there's lots of reasons. In fact, we'll get to it. So signals, what are they? You can signal back and forth. How do they come into mix? So this is where the main title of communication comes in. So ultimately, most of programming, this is wrong. Ultimately, most of programming is about writing messages in some form and sending them around. You know, the logical way to look at it is like you're writing a message and you're sending it around, you're calling it, and those messages are composed of data and arguments and all that stuff. But that's what's happening. There's lots of different ways that that's manifest, but at the high level, you can think about programming as being a bunch of things just communicating with each other. And so I want you to think about that when we go into just plain old functions. So let's do another plain old input and output, but it's more than just input and output. And we're going to talk about that. I actually have a note here about arguments not being return values or not output. So we're going to do that. So the first thing we're going to do today is write a function. Well, we've already done this a couple times, but this time when we do it, we're going to talk about inputs specifically. We did do this really briefly one day, and then we're going to come back to it. So I'm going to go back to the good old greet command. And so let's, I do this every time, and it takes time, but if you want to chime into the chat and tell me what to do to make one, I'm doing it over again every time. That's, repetition, right? So we're going to do that. We're going to say touch greet again, chmod plus x greet, vi greet. We're going to put a shebang in here, bin sh. I just wrote a really beautiful shell script today, according to my boss, who I submitted it to do a Helm 2 to 3 transition in Cloud Native. If you don't know what that is, that's Cloud. So this stuff is, I just got paid to do it today. It's this exact thing that we're doing. And one of the ways that I made sense of everything that I was doing and was able to test it was to break everything down into its functions, into its, subroutines or procedures. Just break it down. I wish we had some good words to use there. So many academics have fought about what words to use that now we don't have a really solid set of words to use. I don't like saying function. It's not really a function. So subroutines, right? So we'll say, let's do the one again. So like echo, we already did this, like hello, right? We did echo hello. I'm going to do the whole sentence for you again. And then we're going to say, so we can say, actually, let's do greet. Actually, let's do a different one. Let's do say hello on this one. And again, if you know other languages, those parentheses they're not used for anything. They're just there to indicate this is a function. If you do this in Bash, you can put function here, but don't do it. Just don't do it. There's no reason for that. Just no. So now how do we make it work? We call say hello. Now say hello, I could also call ls. So for all intents and purposes, looking at this file, running ls to list all the files in the directory and say hello are the same thing. That's what I'm trying to tell you. This is the difference between a subroutine, function, procedure, whatever you want to call it, and a command is zero. There's literally zero difference when it comes to shell scripting. This is what's so great about it. So you do greet like this, and it says ls, and it lists out all the stuff there, right? I could do ls-l readme.md, and I can run it, and it's fine, right? So this thing here, and this actually is one of the very unique parts of shell. So shell is designed to help you make things that are usable from the command line. And if you've come from any other language, this looks very foreign to you. It's like, wait a second, you're calling say hello there. Whereas in any other language, you'd have to have this there to tell what to do. And you can't, by the way, this is a call. So let's back up. So this stuff here, these 3 lines, this is a subroutine, procedure, function, definition. They call it function in the man page, even though it's not. It's obviously procedure. And then what? And then you call it. So unless you call it, it ain't happening, right? So anytime someone says, okay, then somebody might be asking, Well, what's the difference between calling and executing and running? Almost nothing. Let me show you. So, and I actually do this a lot. If I rename this program to greet, yeah, if I rename this program to if I remove greet to say hello, and now you see how it's literally the same thing. In fact, I can do say hello. All right. And if I do this, so I can actually run say hello, and it's the same thing. So as you can see, all I've done here is encapsulated what I could have just wrote here in the first place. What I'm trying to show is that a file, a script, can be considered a big function or a big command. And in fact, in Python and JavaScript and Go and Rust and everything, the file itself can be imagined to have big old curly brackets around the whole thing. Okay, so this is the whole inception idea, a dream within a dream, right? We have a command within a command. We have a block within a block. And we talked about scoping, things living, you know, only within the brackets or living throughout the whole file, right? Well, in Shell, everything lives throughout the entire file. It's called global. And so there you go. From being executed as an interpreter walks through the file line by line. The echo hold line from being executed as interpreter. All right, well, that's a good question. Let's actually watch exactly what the interpreter does. Another great thing about Shell. If you put set-x, it will show you every single line of thing that it does. And this is why I maintain the proper name for those things is a subroutine, because a subroutine is something that you just jump to and then continue on line by line. And that's exactly what's happening. So this is, see, look. So first thing it did is it ran say hello, and then it got to, and then it jumped up, and then it ran it. So let's go through this step through again. So it's important that you understand how computer language interpreters work. The first thing it does is it parses all of these little things, these tokens up into tokens or lexemes or whatever you want to call them, and it creates an abstract syntax tree, which is a reason for you sometime to pay attention in data structures and algorithms class in your computer science. Then you'll understand what an abstract syntax tree is. You might not care about it in any other way. And then another thing, algorithm, goes through that abstract syntax tree and translates those tokens and things into code that it's already written, and it calls it and passes it on to the computer. So that's how it's considered an interpreter. And so what does it do? The first thing it does, okay, so let's step through this really quick, and we're going to get to the arguments and communication promise. So the first thing when you run it, let's trace it. When we do, the very first thing that happens when I hit enter is the computer says, okay, you want to run something in the current directory called say hello. It looks for the file, it sees the file, say hello right there. It looks at the file and it goes, okay, well, since you want to run it, is it runnable? And so it looks at the file and says, is this even a file that can be executed at all? Does it have execute permissions for the current user? We talked about it on a different day. And it says, okay, great. And it said, well, what kind of file is it? I can't tell. And it essentially runs something like file_hello inside its brain. And it says, oh, this is a POSIX shell script. Okay, but how did it determine that? It looks at the first byte, which is 8 little ones and zeros, and it says, ooh, it's a hashtag. And then it says, what's the next byte? I mean, I'm over-exaggerating. It's probably more than that. It says, oh, it's an exclamation point. Okay, that means the rest of this stuff is going to tell me what the interpreter is. And so the computer reads all that and says, fine, I'm gonna, this is the interpreter to use. Got it. And that's how this file program can actually tell us what kind of thing it is. And at that point it says, great, I know what I'm doing here. And then the computer says, okay, I'm done here. Hey, you shell interpreter, I'm going to give the rest of this work over to you. And then it sends the whole stream of data, all the ones and zeros and everything after this, beginning with line 2, to the SH program that's now running. Up to that point, it was another program that was running to figure out who to hand it off to. And now that program has control and it's getting all of this stuff coming in. So it gets this command, it processes it and goes, okay, we're just setting a state here. I am now in debug mode. Awesome. Okay. It doesn't print anything out. It just does that. And then it goes, that's information for the SH interpreter itself. And then it keeps on going. First class object. Yes. And then we come down to, but they aren't in here, unfortunately. I wish they were in real, and they're not first class objects in shell. I wish they were. So we'll get into that later. So we get to line 4 and it's like, ooh, okay, what do we got here? And it's like, okay, I have a token, say hello. Oh, it's got these parentheses after it. Therefore, this is, remember I told you about the interpreter breaking up into tokens and then translating the tokens and applying logic? Well, the interpreter says, I have a token and the token is followed by parentheses. Oh, that means it's the beginning of a function declaration. It means here comes a function. Let me check on that. Oh yeah, sure enough, here is a curly bracket. That means get ready. Here comes a bunch of commands that I'm going to save in my memory for later so that I can run them when I'm asked to do so, when they're called. And so then it like, hey, fine, I got a line. It pretty much doesn't care about any of that. It just tucks it away. It may actually break it down into its actual commands. It depends on the interpreter. I don't know how this one works. So then it puts this line and a couple more. It kind of saves it away in its brain as if it had, had a program just available for that moment. And then it comes in and goes, okay, I'm done with that one. Now, if I had another one, it would do another one. It would add this. All the compilers, all the interpreters are different, but in general, it would add it to something called a symbol table. And a symbol table is like, it says, okay, I have a pointer for this function, and there is a token called say hello that refers to all this code that's saved in memory. And now I'm going to go run that when someone uses me later. Right. And you'll find that this idea applies at every level of computing, all the way up to the highest and to the lowest. It's like, I've got some things that I want to run. That's why I like them called a subroutine, and they're here and they're associated with this pointer, and that pointer has got a name that a human can use, or more than one, and then it's going to run. We're getting into C. You're going to see this a lot when we start coding in C. So then it comes down to here, this line, it says, okay, nothing here. I'll just skip that. And it gets to this token. It goes, okay, wait. I got another token here. Oh my gosh. It's like, okay, this token doesn't have anything after it. But I already have a token with all this code tucked away associated with it in my memory that goes with this token. Therefore, this must be a call. They must want to run this program, this little miniature, block of commands that they've just named. And so it says fine. And then what it does is it actually pulls that out of memory or whatever, and it goes and it jumps up here and runs it. So let's do that again. So it gets to here, it goes fine, set that, fine, okay, define the function, good. We get down here and then it says, oh, execute this. Okay, then it says jump up here and effectively begins executing on line 5. So it's as if you had written that, well, we're not going to do abstractions right now. We'll get to that another day. So it's getting up here and it's just running it. So that's what's happening. So the key thing to take away here is that this is the primary way of communicating with regard to functions and commands. Is you make one, and the very basic way is a call. So this is a function call or command call, whatever you want to call it. The documentation calls it a function call, but please watch the videos about why I hate that term. I'm just using it because they've chosen to use it. And then it says, it jumps it and it runs that. Okay. Now I can have another one right here. I can say hi, right? Say hi. And so we're going to say echo hi. Whoopsie. I'm going too fast. Speaking of which, there we go. Say hi. Echo hi. Hi there. All right. So, and then if I do this here, if I say hi, I can put this here, and there's this. So you could actually, I can kind of imagine a line. In fact, some people will actually draw a line here like this, and some people will go even further and do this. And I actually recommend as a beginner, you probably do this. I do this all the time anyway, because it allows me to test things much more easily. And Python has its own syntax for this. But what you can do, you don't have to do this, but I just strongly encourage you to get in the habit of doing this, because now nothing runs unless you call it. So when you're writing your code, you're thinking of, I'm writing a bunch of little programs inside of my bigger program. In other words, I'm writing subroutines within my script. And so now, of course, that's not going to run, right? Why? What am I missing right here? Anybody want to tell me? To make this program do something useful, what do I need to make it do now? I'm missing something now. What did I miss? Anybody want to guess? Want to guess? Yeah, we need to put the main call there, right? Yeah, right, main. Thank you. So we need to put main there, because otherwise it won't do anything. The reason that I like this approach is, like, I did this all day today. Okay, so the script I wrote today is changing the production namespaces for hundreds, if not thousands, of users. Okay. And there's no really effective way to test that at that scale. I can test it on myself and stuff. But so what I did by doing this was I improved the safety of it by saying, I don't want to do main. I just want to test my one function, say hi for now. Right. And then I would do, let's move it back to greet. I'm going to move it back to greet again. So greet. So this is hi there, right? So the point about this approach, about using the main approach, is that you can, sorry, Pomo, you're going to have to go to bed. So the way of doing this is so that you can individually, it's like writing a whole bunch of programs, and then you can test each piece of your program one at a time while you're writing it and getting it really down well, right? In fact, if you're even really scared, I did this. I actually did this very thing. I put an echo in front of my commands, and then I can test my hi program, my main program, without actually doing anything. I can run it, and it tells me what it would have done. And so when you're talking about doing things that are really dangerous, and then I handed that off, and I put it to do this, and I said, now when you're ready to activate this extremely dangerous code, if you get it wrong, go delete this, and then now it'll do it. Now, in my case, I know it's not too dangerous, so I can just run it, and you'll see it does the right thing. But by using this technique, you can, at any time, you can come in and retest a piece of your code. And so I know this sounds crazy to use the word testable and shell in the same sentence to a lot of people, but this is one way to make your shell code testable. And you should be thinking about, how am I going to test my code as I go forward, no matter what's it being asked to do. It also makes it easy because when you start to write down here, if you simplify this a little bit, I know it actually starts to look like a program that you might just run on the command line, right? Hi, hello, something like that. All right. So that's been about a half an hour. I'm just gonna take a pause. Does anybody have any questions about that? I mean, if you have, now's the time to ask a specific question. If you have one that you've been just dying to ask that's related to this. If you don't, we're gonna proceed with how to do more with communicating between everything. So that we can learn how to do that. Okay, so so we did this yesterday. We're going to do it again. Do you have a question? All right. The first thing I want to practice here is, can we call functions without main? You absolutely can. Yeah. It's not, you absolutely can. I only did that. I only did this as a convention. This is just a personal convention that I've seen a lot used. It allows me to test different parts of my code. Yeah. If I have this like this, how do I test my code? I mean, it's going to get more complicated, right? But I'd have to comment everything out and then recomment it back again. And so this encapsulation of the code, helps me to organize it. It's also consistent with other programming languages. So Python, Go, C, C++, any other programming language, pretty much any major programming language on the planet requires you to define a main function as the entry point. So getting used to doing it in shell is a good, you don't have to, but it's a good habit because you're going to need to do that with every other major language. it's fundamentally the way to enter the program. And the difference in shell is that, I mean, in C, if you compile it, it just runs, right? That's the thing that runs when the program runs. In shell, we actually have to do a little bit of extra magic and say, no, I actually want to call that, right? So as I said, some people in Python is really good about doing this, but they have a really strong separation. In Python, these two things are actually included. You have if name equals main to distinguish between them. It might have some Python coders here, but if you approach this way in shell, when you put a program in Python, it'll just make way more sense to you as well, because you're like, oh yeah, the main, all the stuff under the line is main. Well, even in Python, they will write a main routine, and they'll still call main just to keep things nice and clean. All right, so end up rewriting it in Go all the time. In fact, that's one of the common. That's the common way to do things. So I will start with a shell script. You'll see me. My dot files is filled with shell scripts that were little utilities I just needed right in the moment, like my Zettelkasten thing or something like that, right? And they will grow, and they will grow into something that I need more of, and it'll get bigger. And the next step is almost always for me to write it in Perl and flesh out how it's going to be used, what are the interactions, what's the tab completion, all that sort of thing. And then I'll go with Go. I'll jump to Go. Sometimes I'll go right from shell into Go. But as the program as the utility of the thing you're making grows, you're eventually going to need a real language like Go. I mean, Go is, did you see this post today? Let me send you guys a link that I just read today. It was just amazing about Go. We will come to it at some point. Somebody sent me this today. And since you just reminded me of it. So Khan Academy ported their main system into 500,000 lines of Go, and they wrote a whole review of it. And it's really interesting. And I'll just let you read that and make your own conclusions about it. So that's one of the ways, to go about this, the progression. Sometimes you might need to go smaller, right? There's people that need to go assembly and they need C, right? But I'm more of a utility hacker, cloud native person. So the solutions that I need are in the scriptable command line space. They're not in the web space. They're not in the high-end performance graphics space or the high-end, phone switch space like Erlang is, and they're, or in low-level edge computing and embedded, which is, C and assembly. So it's the right language for the job, as we've always said. Let's start talking about passing data, communicating between subcommands, functions, procedures, whatever you want to call them. How do these things talk to each other? Well, the first way is to just call one. So we already talked about that. Whoopsie. So we already talked about what it means, what a function call is, right? So the first way to communicate is to just call the thing, right? So this says run up here and run hi, and then run up here and run hello. That's the first way of communicating, a call. Now the second way of communicating would be to give it something, to pass on some data to it, and this is where the mathematical function kind of idea comes in, and we're going to give it an argument. Right? So let's change this whole thing to greet. I don't know. You could do a bunch of different ways. So let's say I want to say hi to Rob, and I want to say hello to Rob, right? So we're going to go say that. Now, right now, it's just going to say hello, but we want to say, well, how do I get Rob into here? Okay, well, we've already talked about this. You better remember. How do I pass this argument into a parameter? How does shell do parameters? Yeah, $1. Good. So, and I know this is simplistic, but I just want to show you for right now and keep it simple. So $1 is the first argument, right? And so now it will do that. And so you can see how it communicated, right? And it seems a little redundant, plus not to mention it's kind of hard-coded to just do Rob. Wouldn't it be cool if I could pass it in? Well, what if I change these to be $1, right? All right. What if I change those to be $1? And now it won't work though, right? What's going to do? It's not going to work, right? Why not? Why ain't it working? Somebody tell me what I'm missing. I have a parameter. I have parameters all over the place, but what am I missing? I'm missing the arguments to go into the parameters. The stuff, yeah. And so I need to pass to main. Yeah, I need to call main and pass it. I'm using the words computer people do. I'm going to pass it a string called Rob as a function name in scope in a file before its declaration appears. That is a great question, Brillen. In shell, it does not exist. So that is because, okay, this is such a great question. I'm so glad you asked that question. So, because I would have missed it. In fact, I want to make sure. I want to make sure that we put order of execution in here. Position of. Let's see. We have to put calls must come after declarations. This is not true of all languages. Languages vary radically on this particular point. What Brillen's talking about is the if I try to, so let's first of all get this to run. So as you can see now, it's working, right? So let's follow the path of communication real quick, and then I'll come back to that point Brillen made. So Rob, this says we're gonna, so it's declare, stored in my memory, and then run it. Call main. So main gets called, Rob gets passed into it. These I like to, it's so in this case there. By the way, if you know other languages, this is super confusing for people who do. Nothing goes in between the parentheses in shell ever. It's always $1, $2, etc. So Rob goes into $1. That's the parameter, and then $1 can be used, and then this one calls hi $1. Well, $1 is no longer $1. $1 contains Rob as a string, so this is the same as calling hi Rob. So it jumps up here and it says echo hi there. Well, what's the $1? I passed Rob into there, so then it says hi there Rob, and it jumps back down here, comes to this line, does the same thing. So you can really think of these as being commands you would execute on the command line. Yet another reason to learn shell as a first language. Also call the function without, yeah. If you've done any Python or JavaScript, you're really confused because right here, I don't want to confuse you more, but normally you would have like an x comma y here, and you would have x be the thing that's passed in, y or something like that. That is not the case in shell. That is not the case in shell. It's the same with JavaScript. It's the same with Python, Go, C, and every other language. Shell is very different in that regard, and it's one of the many reasons that I've hesitated teaching shell as a first language up to now. But if you can just replace that in your brain with $1, $2, $3, $4. In fact, all of the arguments combined are also in a special variable, which we're going to talk about in a bit. Calls function A cannot call B because it has not been declared yet. Yeah, so let's try this. What happens if I put main up here at the top? What's going to happen? What's going to happen? Anybody want to guess? What are your bets? What's it gonna do? Again, experiment, explore, break things, X and RWX. So we're gonna go break something to learn something. What do you think is gonna happen? Functions are not in scope. Anybody have any other guesses? Errors? Yep, error. What the hell is main? I love your guys' answers. It's worth it for me to just hear your answers. All right, so here we go. / greet. What'll it be? Already on main, your branch is up to date. What? That is a weird error, isn't it? Do you see what it did? Was not expecting that. Why did it do that? This is actually really cool. Yeah. What have we learned here? Yeah. Because nothing else up here had been declared, the computer did its best possible. Remember all that stuff about being careful what's in your path? It did its best possible attempt to find a main. And so it ran my main script, which I don't even know what it is. This is what it ran. I didn't know I had that. I should probably get rid of it. I am going to get rid of it right now. Because I don't want it to get in trouble with it. So there you go. It wasn't declared, so it did its. That's actually dangerous, right? That's dangerous because it could have. I mean, I might not have wanted it to call main. What if main had done something completely wrong and broke my system and stuff, right? So I'm glad we did that breaking to learn thing because I found something. So I'm going to remove that script. You don't know about this yet, but pretend you do. So we haven't talked about position these variables yet, so I gotta do that kind of fast. This actually, what this does is see these backticks. I'm jump ahead. Backticks will be replaced with the output of that command. So that is exactly the same. There's no main anymore, but let's say which ls, right? So if I wanted to say, oh, I don't know, you know, head -1 ls would be like, there's no ls, right? Well, if I want to get user bin ls, I can do which ls, and it will replace that stuff between the backticks with that. Now, backticks are nice and handy on the command line, but yes, but the proper way to put them is, well, I was gonna talk about this later. It does do a new subshell. Yes, it does. So, and when you're writing them in scripts and code, you want to do it this way. They're exactly the same. The difference is that with this, if I wanted to say echo, if I wanted to have another one in here, and I said echo ls, I mean, that's actually a thing. That's actually a thing, yeah. So I wasn't going to explain this until later, but I might as well now. So you should always use $ parenthesis notation for that. But sometimes when you're just like writing really fast, it's easier to write it like this, you know, which main. So there is no main in that case. It just didn't do anything. So anyway, we're going to come back to that. That's actually a method of communicating that's related to output and return values and stuff like that I was going to get to a little bit later tonight. So we'll get back to that. Where am I? Exit. Exit. Okay, so back to greet. Run which made automatically. Yeah, I wonder if it would have caught it. Let me try. Shell check. You guys remember about shell check, right? I haven't been using it. Bad me. You missed why? It's preferred because it can be nested. Let's try to do that same thing that I just did. Without it. So you remember how I did, I don't know, head 1. I was like doing something silly. You know what I mean? If you try to nest backticks, you know, you can't because they don't nest. The single reason, not only is it safer, the only reason you should use backticks is because it's easier to type. So you'll see me do this all the time. So I have a command. Oh boy, I suspended my terminal. I actually suspended my terminal. There, you saw it. You saw it happen. Backticks can't be escaped. No. And heaps are more readable. Yes. Well, so I have a tool for starting up my workspaces. You see how this started my last workspace, right? Well, if I wanted to go into the directory where that workspace exists, I'm just giving you a practical example. WSD will show you where it is. But I want to go there, right? I don't want to be told where it is. I want to go there. So in order to do that, I could do CD, you know, and I go WSD, and it will take me to the right spot because it replaced all that long thing with looking up where it is. I find myself using backticks a lot when it's involving CD and so like mostly because you know, I can already hear the Z shell and other people coming out of the woodwork and fish people going, well, you don't need that in there. Yeah. Well, you know, you don't already have that. So you should learn backticks anyway. Backticks are useful. I mean, another one would be like, I don't know, ls, you know, if you wanted to like make a date file. So, you know, you can make a file that's named after the date. Well, there you go. I got files everywhere. I'll clean it up later. That was stupid. Let's do a better one. Let's do, I guess we're doing backticks right now. I wasn't planning on it. So first of all, like maybe you should build it up, right? So let's actually do this well, not like morons like I just did. So y, experiment, people. It's how you learn. I'm doing it live on my own system rather than a container. I'm dangerous. I'm playing dangerous. Well, we don't know about date yet. You can read about this in the man page. Month and then percent. What is it? I want to say day. Yeah, there we go. So that's a nice timestamp. That's much better, right? So if I do this, it'll actually do it and not do anything. Oh wait, it tried to run it as a command. What? Keywords in the languages. Yes, it is. Xargs. No, not always. Xargs works for for a lot of those cases, but not always. In this case, it doesn't work. Yeah, this one would work with Xargs. Yeah, I could do Xargs here, and I could say, what would we do here? Date, touch, or I don't know. You know what I'm saying? Like that actually would work in that case. But you don't. I mean, Xargs doesn't always work, particularly if you're like doing multiple nests. So I tend to do, yeah. But I'm just trying to think if there's any case where Xargs would be preferable to backticks, and I don't use Xargs very much, so I can't really think of anything. But I would do this kind of thing, and that would make me yet another file. Oh, that didn't really make another file. If I were to put seconds on here or something, and by the way, that's what isosec is when we talk about. So there's the isosec, right? So another, I would do this when I my Zettelcast and stuff. I do this all the time. So I do this. I could touch isosec, and it will make a new file for me that has the isosec in it. So much easier to type, right? And even slightly easier than this. That's, I mean, I can type that too, but it's not as easy. I'm making a big mess of my directory. I'm going to have to clean it up later. Oh well, it's all for the sake of learning. So let's go back to communication. We got to get to signals before the night's over. We got what, 40 minutes, 50? No, yeah. So here we go. So we got back to greet. So obviously putting main in the front was a bad idea because it tried its hardest to run it, but I want it to run this main and it has not yet been defined. Now, I'm going to tell you right now, every other language that I've ever used, that does not matter. In fact, I'm going to test Python right now. I do. Greet py. I know I didn't touch it first, so what? Bin, user bin, Python 3, I think. My Python is so rusty. I haven't written any Python in, God, a month or two. So what would we do? Greet, it would be, somebody help me. Def greet. Oh wait, no brackets, no brackets. I used to do polyglot programming where we would learn at the same time. So we're gonna say greet, and we'll have name be the thing here. And I know it's 4 spaces by default, and I mean that's what is it, pip 8, pip 8401 or whatever one is, the one with all the styles. Greet. Print, we gotta have the parentheses because it's not Python 2. Print name, print, no, let's say hi. Let's make this one hi. So it's like say, we say hi, and I mean, this is not normally how this is done. So there's actually a better way to do this in Python. Is it pep 8? Yeah, they get it. I'm not that old. So down here, there is no main, but if we do, so we can actually just call hi. Now normally, actually in Python too, you would have, I mean, why not? I'm actually reconsidering this. I might actually teach really basic JavaScript, Python, and Shell at the same time, because comparing those shell languages to each other is useful for you to kind of get a sense of these same concepts in the different languages. I call it polyglot programming, and I taught Go, Shell, and JavaScript at the same time. I did it in one semester. It took forever though to do it because we'd have to, we did everything in all three. But at least at this point, maybe you can see this. So if name equals main, and then what? Then do that. Then do this. Then do hi. You like the polyglot? I think polyglot programming is for this particular kind of. We've already been doing it. right? We've already been doing it. You've seen me like show you in JavaScript how this works and stuff. So here we go. So we've got, so let's just do it for today. So we got name Rob equals hi there. And what? Then what we got? So is that going to run? I don't know. We're going to see. Don't tell anybody I made an alias for it. Shh. You want to see my schmucks alias? I think it's a script. Schmucks is schmucks because I'm too lazy to type a plus. I know. Anyway, so greet P. Hi Rob. All right. So that's the same sort of thing there, right? And let's see how, the variables passed in and everything. Now, strictly speaking, a short polyglot class on LinkedIn, don't remember anything? Yeah. Polyglot means multiple language, multiple tongues, if you speak more than one. So I love me some F strings, and so we're going to use an F string here. I'm going to do hi. Awesome, sure. You like that? I schmucks lots of stuff. Plus, it's easy to say. So touch high. Yes, you got it. Ivory. We got some Python people in the house here. You don't need this. The new improved. The thing about Python's been around for so long. There's no less than 4 ways to do what I just did by substituting the variable in and at that location. And so that is the new hotness that Python 3.6 above, I think, gives us, right? So that's cool. But who will schmucks the schmucks? This is string interpolation, yeah. So this is called an F string in Python. Are we going to do the poly thing? If we're going to do the poly thing, we got to see node next to it then. So, because JavaScript does this too. I might actually have to have you guys install node and npm and stuff. Do I have node on here? I do, right? So we're just going with it. We'll just go with it. So greet.js. Ben, I don't know where. I don't know. Wait. I'm gonna use watch. Which, you watch this? Okay. Which Node.js? Right. Remember my bang bash. Oh damn! It didn't work. Damn it! It didn't work. Why didn't it work, people? Maybe because they don't have Node here. Internet's breaking up. Install what? Node.js. Yeah. Node.js. I know. Chitty bang. Yeah, here we go. Bash. There we go. See that? What just happened? Did you see what just happened? Boom, boom, bash. Boom, boom, bash. Boom, boom, bash. Why not Dino? Oh, I think that's a great idea. And we can give Dino some love. I love me some Dino. Let's do Dino. That's a great idea. You're brilliant. I even have some Dino on here. People make fun of Dino all the time. Where's my Dino? No Dino. Damn. Okay, well, this is all from the cuff. So we'll do it. Next, you know what? Tomorrow I'll have that for you. We'll start doing it in Dino. Dino's better for the command line anyway to learn this stuff. And plus it teaches you TypeScript. So it's way better from the command. You don't have to go through the whole Node ecosystem. And then if you want to do Node later, you'll be prepared for it. But Dino for writing scripts and stuff is way better. Anyway, so what was I doing? I don't remember. Oh yeah, shebang. Dino, yeah, Dino the dinosaur. That's our mascot. Yeah, I love Dino. I love it. I know people bag on it all the time. It's not really for production and everything, but I love what they're doing with the project. And I really love Ryan Dahl. He's one of my favorite technologists on the planet. He's just he owns the fact that he was just experimenting with Node, and he's like, yeah, I learned a lot, and I screwed a lot of stuff up, and now I'm doing something more. And he has the courage to just own it like that instead of get dogmatic behind it like so many other people do. So what do we do here? Console log. So I don't even remember. Oh God. Are we going to do fat arrow functions? I think we are. You guys are going to really test me here. So node hi. I'm going to do the only way that I like to do functions. So functions are constants. Bet you didn't know that. This is why I love JavaScript for teaching beginners. Because talk about your first class functions. Where are you, Brilliant? Are you there? Here we are doing, I like your emojis. Here we are doing first class functions. Yeah. You wanted them live, fat arrow functions, first class functions. That's why I love teaching beginners JavaScript, because it teaches true computer science way better than Python. I mean, you cannot teach true computer science with Python. You can't, because it doesn't have anonymous functions, people. Okay, so here we go. Don't tell me lambdas are anonymous functions. They're not. They're one-line pieces of crap. So here we go. And then we'll have this equal. We'll actually make it a block in this case. But we don't need a whole block. We can do what are we going to say? Console log. That's print, right? We're going to leave semicolons off, and you're going to lose your crap over it. But I don't care. You don't need them. Go watch the amazing YouTuber who calls out all the reasons you don't need semicolons, and that they can actually hurt you. So here we go. We're actually going to use the newfangled backtick notation, yeah, which is super cool. And we're going to say hi name. So these are called These are not F strings. These are called what is the name? String literals. Template literals. That's right. Not string literals. Template literals. They're called template literals. Yep. And no, I don't need that. I don't need that. Do I have to have a dollar in front? I do. I forgot. Yes. And my syntax highlighter doesn't know what to do. It's confused. Yeah. Oh, ES6 added some amazing stuff. I mean, it did. It made it like as cool as, like Erlanger Haskell in some sense. It started. The syntax is just the bar. I cannot wait for the bar operator. You guys know what I'm talking about, the pipe operator, and then you can like truly functional programming in JavaScript. I mean, I told you it's one of my favorite syntaxes. And modern JavaScript is one of my favorite scripting syntaxes I've ever experienced. ES6 has destroyed the. It did a lot. It did a lot, not all, but so anyway. How do I run this? I didn't even make a main. So let's just run our program. So to do this, we have to call hi, but we have to give it something, right? So we're going to give it the name Rob here. Now I can use singular, or we need to do this whole thing again. We might have to revise. I tell you what, we will do. Normally we'll take longer to do all of this, and we'll learn all the languages at the same time. But since we started, I'll make a command decision here. Since we started with shell, we'll finish shell this week. We'll do command interactions, right? And then we'll immediately start with Dino. And then after that, I'll teach you the exact same thing in Perl and the exact same thing in Python. So you'll learn 4 scripting languages before we go into anything else. And frankly, that's really great, because then when we go into customizing your environment, you'll be able to pick from the best language for the best job for that kind of thing. All right. So, and you can compare them again. Man, you'll be so boosted. You won't know how to come down. You'll be like so high. And emphasize absolutely. We definitely need to emphasize the pros and cons. And that's, I'm already doing it. Right. I just told you about global variables and all this stuff. So, and this is my natural way of teaching it. And it's funny that I kind of fell into the polyglot approach, because it's my favorite. I actually have started 2 different books, become a polyglot programmer, learned to code in 6 different languages. And that's a book I actually have started. I've got probably 80 pages of that book finished. And I gave up on it because I was like, man, I don't know if anybody's going to read it. But if we keep it at the simple level, on the scripting level, I think we can really draw some safe comparisons there. The truth of the matter is that people are not going to hire you because you know how to code in shell or you know how to code in JavaScript. They're going to hire you because you're a programmer or because you're a technologist and you know how all this stuff works, and you can pick up any language instantly by just having them teach you the syntax. So becoming a polyglot is an essential part of becoming a beginner. I just figured the next language was going to be C. But I think if we did 4 interpreted scripting languages, which are the things you're going to use every day, all the time, and then we did a really serious language after that, we'll do C after that, and then we'll do Go. Now, the thing that's really great about Go is that Go fits between the really serious C language and the really loosey-goosey interpreted languages as a utility language. And that'll put you, I mean, you'll be set. And that'll probably be it. That'll probably be it for the boost, actually. At that point, you just, go forth and produce. It's not easier to distribute than Python. It depends what you're distributing to. Python is one of the worst ever languages to distribute. And that is what we're going to have a day kind of after we cover all of the languages. We'll have to have like a day or two of summary where we just talk about, well, when would you pick this language now that you know it? When would you put this language? And we'll actually ask you to answer that question. Which one of these languages feels better for this specific task? Which one of these would you pick for this task? You know what I'm saying? So you can learn to pick the right tool for the job instead of becoming a one-trick pony, and fighting with everybody else about how much your language is better than everybody else's, which just makes you look like an idiot, because nobody in the professional world respects that. They respect people who can adapt and learn to code in whatever language is needed for the job. And sometimes have problems with it. Today I wrote the entire thing in Perl, and then I backtracked out and wrote it in POSIX. Actually, I wrote it in Bash. This true story today. Okay. So today, and I'll get back to it, I promise. So today, while I was given this assignment, right? So I wanted to do it fast and it was fun and everything. And so I thought, well, okay. And I had to think about, well, what language should I do this in? And he just gave me some pseudocode. So he really didn't know. He knew Python. And I was like, okay, well, if I follow my own advice, I should do it in POSIX shell so everybody can use it. But it needs to be written fast and it needs to be robust and stuff. And, if I use Bash, I can get away with these extra things that I don't have in shell. So I wrote a Z about why I think Bash could be useful for the enterprise, because if you're making a Docker file on Ubuntu, you can use Bashisms just fine. Nobody cares. And you can avoid the hassle of, subshells and stuff from POSIX and blah, blah, blah. I mean, we've talked about all these things before. And then I was like, I could actually even write this faster and in fewer lines if I did it in Perl. So I wrote it in Bash, and then I rewrote most of it in Perl. And then I threw it all out and went back to POSIX shell, and I got finished by 5 o'clock because I was like, I kept going back and forth, and I'm really, really glad I picked shell. You know why? Because the answer from my boss was, this is absolutely beautiful shell code. That was really nice. It made warm my heart. I gave him a smiley face back. And because the person that was coding it for and the rest of the people on my team are all older, not old, but older. They've all memorized POSIX shell perfectly. Some of them know a little bit of Bashisms, but couldn't be forced to do it. And they all know Python, but they would probably not do Python here because there were a lot of, shell integration going on that Python's really bad at doing. Python is a horrible shell scripting language. It's not for that. We're going to get into that later. I know you think it's fantastic and all that stuff. It's not. And I'm going to show you why. But because the same exact thing would have taken me an extra hour, right, in Python. And it's not just because my Python's rusty, right? And God knows I would never have written this in Node. If I had written this in Node, they might have fired me. Because it's so not the right. I could definitely have done it, but it was just so not the right tool for the job. If my entire team was web developers and they were all doing different things, then yeah, they probably would want it in Node or Deno. So you got to kind of read the room when it comes to picking a language it's going to be and how it's going to, even if it's a throwaway. This script is a throwaway. Anyway. That was a nice break. I took a break even though I didn't intend to take a break. And I wanted to use multiple languages on the same project. Yeah. I kind of wanted to make all three and say, pick your favorite one. Then they just would have yelled at me. They'd be like, why did you spend all the time writing in this? I just couldn't help myself. When he saw there was a Git repo that I started out using Git, even though I didn't have it, published to GitHub or anything, what his first response was? Appropriately, his first response was, this is just a throwaway script, right? I went, I know, but what? It took 2 extra commands, git init, git commit, in order for me to have a backup copy as I'm at development. I'm really glad I did, because I was able to go back and get it. We're going to cover Git. In fact, we're not just going to cover languages. We have to cover tmux. So I think we should probably do this shell scripting languages. I think this is what we're gonna do. I think we're gonna do shell, and then we're gonna do all the customization that you guys are dying for. I know you are. You want to customize your bash terminal. You want to customize your vimrc. You want to use tmux. I've been putting all that stuff off because you didn't know how to code yet. And then we'll come back to the other interpreted languages. Possibly. I don't know. What do you think? Did you hear Oxide release their details? They did? Oh boy, we got to look at that one. I mentioned both of Jess Frazzle and Brian Cantrell before on the stream. Amazing technologists. Willy Wonka containerized workstation. They made their own business, Oxide Computer. We definitely want to go look at that. It's gonna be a fun thing to go look at. They're gonna change the world. There's some of the next, like the next generation of Steve Jobs and people like that. There are young people that are of that caliber, and that group is definitely among that group. I'd love to see what they come up with. Okay, so here we go. We have back to anyway. I mean, if we keep it simple, we can learn this at the same time. I don't want to delay other stuff. That's always been the problem with Polyglot. Because I know you guys are chomping the bit to get to other stuff, customizing things, and you're like, well, I don't need to learn JavaScript. Okay, so that's how you do it. Oh my gosh, what happened? Why am I such a mess here? Let's schmox. It's not schmox, right? You know what schmox is, right? Schmox greet JS. The idea show was to be literate in config files. Yeah, I know. And frankly, the config files are in all three interpreted languages. We still have to learn JSON and YAML too. We got a lot to cover. It's going to take 100 days at least, right? So, in fact, part of me wants to do YAML and JSON before shell because you can really pull that off. But I think we'd lose people on that. I mean, people would get really annoyed. It's hard because this stuff all stacks in weird ways. There's like interdependencies that are very complicated. All right, so. And I stress that, my OCD on that. I get really stressed on the best possible way to teach you in what order. And I lose sleep over it. Ask my wife. I literally will stay up with a pencil and paper trying to figure out the best possible. This leads to this and this to this and this. And it's hard. It's really hard. All right, so we got our stuff here. We have 20 minutes left. And we've talked about communication. We've talked about, so let's go back to shell. And we'll wrap up with communication. So if I need to send... So the thing with the shell is we've got one. What if I send a last name? Okay. If I wanted to send a last name, I don't mind you knowing. So I would have to do this, right? So I'm doing this on purpose. We're going to stick with shell for a while. So there you go. Right? Now these all have to be except this. I'm doing this on purpose. I'm doing this the hard way on purpose. I'm sure some of you already know an alternative that's much better than this, right? But I want to show you. All right, so if I want to do that, I can do this. /greet. All right, so that worked, right? Now, wouldn't it be cool? Now, a lot of times somebody will do this too, because you don't necessarily know. It's not uncommon to do this. So one, right? So you could say first. Last, you do two here. It doesn't matter. You keep following me here. It's just a little bit easier to read that way, but it's not required. It's just a little more verbose. And when you get done with that, you can read this a little bit easier, right? So they're the same though. They're the same. And so I just wanted to show you that. Now wouldn't it be even better if I could pass, instead of type, this is hard coded to send Rob every time. What if I don't do that? What if I replace this? How do I get, so pay attention, put your ears on, people. Does it have to be, yeah, it can't be. So $1 is automatically populated with the first argument. It's automatically assigned the first argument. $2, and this is just so I can use the names. If I wanted to use these fancy words, I could do it this way, or I could keep it how I had it, like this. Okay, it's exactly the same thing. If you have a lot of code and you're moving around, you're reusing it in many places and you're calling out to different things, you might want to actually put names on them like this, but it's not required. Again, that's the thing about shell. Shell is designed to be as simple as possible and then layer on as you need. And so its biggest disadvantage is both its biggest advantage. Its simplicity is its advantage as well as its disadvantage. All right, so here we go. The next, so here's something though. How do I get this stuff right here? How do I get that? What if I want to get it? This is what I want to do. I want to type, anybody know? Don't look it up. Does anybody know? I want to type Rob Muhlstein and have it greet me. Now it's working right now, but what if I want to type Doris? So I want to be able to change it up, right? How do I do that? How do I do that? Well, it's actually not completely obvious to beginners, and I confuse this all the time. But there is another special variable called $at. And you're going to we always put quotes around this, okay? We talked about quoting everything, remember? $at, you just have to trust me on this. $at is every single argument in order. So it's exactly the same as this, as $1, $2, and so on. Okay, I mean, that's just a comment, but by the way, pound signs are comments. I just turned something off. So those two are effectively the same. Burn that in your brain. That special thing is exactly the same. Now, I'm going to teach you another special variable at the same time that really confuses beginners. And I'm going to teach it to your right so that you don't ever have to be confused again. And it's $, which you should almost never use. But I'm going to teach you about it anyway because you're going to see really bad code that uses $. And yeah, that's a script name. We talked about that before. $0 is a script name, and we're going to come back to that and use the script name for multi-call eventually, but we're not going to do it right now. So this is exactly the same as this. Do you see the difference? Look at that for a long time and make sure you understand the difference. And let me see if I were to do it. Let's actually experiment by breaking them. Okay. So we're going to turn that one off, and we're going to use this one. All right, I'm going to turn this example off, and we're going to use this one. Let me see if it works. And we're going to run that, and we're going to do ./greet. And not going to do anything, right? Because I didn't pass it anything. All right, well, if I pass it Rob, what will it do? Hello there, Rob. That's nice. Hello there, Rob Muhlstein. Okay, that's all well and good. All right, let's actually test our hypothesis here. And let's say echo, just put some lines in between here. And let's do it the other way. Seems to me it did the same thing. It didn't. It didn't do the same thing. This is why beginners get really confused. Because why? Because what it did is it actually printed out. Watch, I'm going to show you. So if I do this, we're going to do hello first day first and then last. Okay, watch this now. So now when we run it, do you see the difference? I know you're gonna have to replay this video a couple times on this one. Alias, yeah. Well, the base name is replaced with $0. Yeah. So this is what I want you to see. This is the difference between these special variables, $@ and $. $* is the same. So this groups together those two things and puts them into a single argument. One of the places you see me doing this all the time, and I already talked about this, is when I use the %. When I do like a difference between shell variables. So you see I didn't put any quotes or anything, right? So what is it actually searching for? Well, it's searching for the same exact thing as this. Why? Because my script, that's DuckDuckGo, does this. It has a $. If it had a $@ sign, it would not be the same. Okay, so yeah, it is good. Yeah, Git is really good. It's not at all relevant to today's conversation, but it's really good. So, okay, VI greet. So we're going to try to get to signals now with the last remaining minutes. But I want you to see about those variables. So we have to do return values next, and we might have to save signals for another day. Oh well. Do you see the difference there between the 1 and the 2 and how it's getting? Make sure you practice with that. Make sure you understand what $and is. And if you don't remember anything else, the exact equivalent of passing everything that was passed to the command itself to the function, this is how you do it. Memorize that. So if you want to make one of these functions the same as if it had just been not a function, then pass $@ in double quotes. That's the way to do it. And that's really all you need to take away from that. I just wanted to leave all of that in there for you. Now, you can also do the same thing here. So every one of these guys also receives a $@ if you want to use it for that. Okay. There's so many other variables. I don't know how many of them to teach you. There is another one that is called I'm just gonna, I don't know if I should teach you this, but so if you echo, if you do $ and you put you know that this extended form, right? If you put that in front of is that it? Did I get that right? I don't use this one very much. Let me try. Let me see if I can get it again. Come on, guys. All right. So that one, then there's, if you want to read about them, you can go read the man page and read about shell special variables. There's lots of them. But these are the important ones. This one you're not going to really need yet. When we start looping and stuff, you might, but $number means how many arguments were there. And that, why do you care about that? Because you can say, we haven't got to conditions yet, but when we do, you can say test if the number, we're going to wrap it. You don't necessarily need to do this actually. That one I don't think you would probably need to wrap. But if that is greater than, or how about this, equals 0, then, well, we don't know conditions yet. I'm running ahead of myself. Then what? So we're going to, let's just say we're going to come back to that. Echo what? And let's see if that works. So let's not do any of these here. So you see what it said? It didn't know who to say, who had to say hi to. And we're going to get to conditions. So stay tuned. I promise we're going to get to conditions. So it's like, what? And is a Rob, like, okay, see? So some of these special variables will have meaning. I'm going to get rid of that right now so it doesn't confuse you. Now, the last thing, I guess, that we have to cover today in the 10 minutes is return values. And I'm going to spend all the rest of the time covering return values. Return values are really, really important. They are akin to, they're what tell you whether something worked or not. Okay, so stuff going in is important to give you information. The stuff coming out is important to tell you whether it worked or not. And this is a natural lead into conditions later, as you saw with the if statement I just did. And we're going to do conditions next. I think I'm going to push off signals until later because that'd be really fun to see in 3 different languages. But so here we go. So what is coming out of it? None of these, first of all, these are not functions, right? So there's no return value. So the first the first bit, and this is in the boost, this is in the document, you can go read it. The first fact is that all subroutine function procedure things return integers. And this is a Unix thing. This is not a, as I've said many, many times, any one of these little subroutines can be considered a mini command within a command, and they all behave the same as a command. So I'm going to teach you right away another very special variable that you will use all the time. It's called $! Yes, they are. That's exactly what they are. Yep. And so, yes. So this is very important. Okay. Let's try this. So ls, so every single command, including commands that are written as subroutines inside of a shell script, returns an integer, no matter what. And if it's successful, it returns a 0. And if it's not successful, it returns any number between 1 and 255. And the reason that is backwards, which everyone immediately asks me, because every other language on the planet considers something not 0 to be true, to be something good, a successful situation return value, and a 0 to be a failure. And 0 or lower than 0 in every other language, Python, JavaScript, everything, is considered bad and fail. In Shell and Unix, 0 means there was 0 evidence of failure. Think of it that way. There were 0 failures. There were 0 problems. And if there is a problem, the reason for this is because the early Unix systems, they would return an integer, and the number would identify the type of error that was being returned. Because the only thing you can return from a command in Unix or a Unix function is a number, and that number is limited between 0 and 255. Still is. You can send negative numbers as well, but I don't believe you can go over that. I ought to try it. And so that number is designed to give you, in fact, some programs will still give you a number that has some significance when really all you really want to know is, was it 0 or not? Okay. So 0 is treated as an int and not as a Boolean. Yes. 0. In fact, everything is treated as an int. However, you could all of the Boolean. So I don't want to get into Boolean conditions yet. We'll do that tomorrow. So so let's just repeat that, Brolin. So in order to get your head around this, think of 0 as there were 0 errors here. Okay, nothing bad happened. There were 0 errors here. Don't think of it as a 0 is negative and a 1 is positive. That's every other language. Okay, so 0 means there are 0 errors, and that will help you remember, because it's super easy when you're a beginner to get confused. It's actually one of the main reasons I didn't want to teach shell at first. Is one of the, there's a lot of them that stack up, global variables and all kinds of things. But let's see what that means before we close out here. So, and then play around with this. Again, you're going to go and you're going to play around with this on your own. So we're going to do this. We're going to say, let's just do an ls. Okay. I want an ls greet. All right. So do I have a greet? Yes, I do. I want to throw away the output. You guys remember how to do this? If you want to throw away the output, if you have bash, this is not POSIX, this is bash. You can say, I don't want to see the output. I don't care. You can send it to DevNull. There's t-shirts with this. Your opinion to DevNull. It's like a pretty popular t-shirt. It's part of the culture. Yeah, send it to null. They're like, I don't care. All I really want to know, and remember, what does a semicolon do? What does the semicolon mean if I put it on the same line? You're going to do it all the time. What does it mean? Okay, but anybody remember? It means get ready. I'm going to do a new line without a new line. All right, so a semicolon means I'm going to do a new line here. It's called a one-liner. So everything on this line is an actual script with multiple lines. The lines are just being replaced by semicolon. Okay, so it happens all the time. It does not work the same if I do this and then I do another line, because that's a separate process. This is something interesting about Unix I didn't really get into. Every single command that you execute happens in a sub-process. A process forks off. We talked about some processes before, but it runs, and then the result, and then it comes back and it goes away and the parent takes over again, and it keeps doing that. So if sometimes, like for example, if you define a variable It may or may not persist something. It will, but in some other cases, something might not happen on the next line because it only lived during that one process that you just ran. All right, so right, but in this case, I'm going to put on the same line, and I'm going to echo our special variable with no quotes. You don't need them, and because it's always going to be an integer. Now, this is a 0, but if I try to list something that doesn't exist, I get a number. In fact, I don't even get a 1. I get a special number. Well, why is that special? I don't know. I don't even know why. I don't know. Let's go see if there's anything about errors here. Nothing about errors at all. Happen in the same thread. Yes, they do. Well, they happen in the same subshell. Yes. But then the thing of it is, Brilliant, is that they actually each are independently subshells of that one. So you can't really see it because it's so fast, but it's forking a sub process, and then the first line executes in its sub process, and then the other one executes in its own sub process. And then they all get reaped back up, and then that gets reaped back up. So it's kind of like this tree that creates and then goes back up. So 2 is the error code. Now let's actually, we're going to talk about conditions tomorrow, so I don't want to spend too much time. Yeah, it's like a tree. So it's a process tree. Yeah, it is recursion. It totally is. So here's the thing. We're going to talk about conditions tomorrow, but I want you to get this thing about return codes, right? Because this return code stuff is going to allow us to combine things. So if I didn't want, by the way, there's one other special variable I might as well mention. It's, oh my God, really? Oh, that's because I threw away the result. Here, let's try this. That is weird. Oh, that's the process ID. What am I talking about? What's the last error? I don't use that one ever. Do you guys remember? I'm gonna have to go look it up. So there's along with the last return value is the last error, and I don't remember it. I'm gonna have to go look. Last error shall. This is a common POSIX thing, by the way. So anytime anything has fails for any reason, it'll give you a return value. No. It's the same. Yeah. So it's the same as C error no, but what's the other one? Error mess, MSG in C. I don't remember it. I should remember this. I don't. I don't ever use it. I just use the return code. But if you want to see the actual text of the error, you can do that. And every other shell language, including, Python, everything, gives you the status of the last command. But I want the error message. Come on. Is there no error message? Maybe it's just a C thing. Maybe there isn't one. I've never used it. It looks like that's true. Yep, there's no such thing. No such thing. There isn't. It must have been just a standard out thing. A standard error thing. That's good. I learned something today. All right. Well, that explains why I can't remember it, because it doesn't exist. So, it's called last error or last error in most other things. But I don't see it. I do not see it. 14 errors and signals. Yeah, we're talking about errors and signals. Signals we'll do tomorrow. It looks like somebody else's. Hey, look, this is a Linux command line book. Yay. Yeah, I'm not seeing it. Not seeing it. Anyway, so I guess just the exit code is all you get. Some other languages will give you not only that, but they'll give you a message that goes with the number, and other languages definitely give you that. I know Python does. Oh, it's not X. You know what? I refuse to give up. We're done here, but let me see if I can go find it. Variables. Come on, where are you? I know you are. Shell variables. Yes. Shell variables. I refuse to give up. Here's all the shell variables and the bash. If you type man bash and just search for shell variables, it's in a dollar. It's in a dollar thing. It's like dollar whatever. No. It's C has this too. So C stores whatever the last error was in this like block of memory that you can go reference, and it's always the last error that was encountered. So here's a bunch of shell variables you can go look up that are available to you in bash. You can do the same thing in shell, POSIX shell if you want to go look. comp line. This is how we do completion, file completion. I do that all the time. And there's got to be some other weird ones though. Where's our weird ones? Did you see shell level, SHLVL? That tells you your position in the tree. Remember you were talking about the tree, Berlin? Remember we were talking about how far down in the process tree you are? So SHLVL will tell you how far down you are. History. Oh, is it? No, it's not star. It's not and. Is it and? It might be and. It might be and. Let me try something. All right. So I know you guys are ready to go, but greet, echo. Oh, wait. Oh no, I just backgrounded the process. That's not it. All right. So we learned the hard way. That is definitely not it. So this is the return code. That's the one you care about, right? We change this, we'll go back to a 1. See this error message right here? See this error message? That error message gets captured in the last error. Yeah, each one does have its own last error. Yeah, it's definitely a C thing. So I don't know. I guess it's not a shell thing. I don't know. Live and learn. I'm not seeing it. So that must be why. So, but here's this. It's worth looking at the bash man page and reading this, or the dash man page and reading the section about special variables and parameters. It's kind of boring, but if you want to go deeper than what I've told you about, you can go read it down here. It's really interesting. So, oh yeah, the previous command. Yeah, don't do that. I mean, people do, but you shouldn't. It's not cool. Refer the most precise. I don't like all these history designators. I really don't. Never liked them. I don't see it. So there you go. Perl has it. Perl has it. Yeah. Perl has it. That's why I'm corrupted. Perl definitely has it. So Perl has all of these and more. Didn't find it? Yeah. So Perl's got, see, it's got argument things. It's got list separators. It's got the process ID. That's another one. The process ID is the currently running process. That's actually nice for unique identifiers and stuff like that. But processes get recycled, so careful. The other great thing about Perl is that it's directly in line with Shell and Bash in terms of variable names. And Python is not. Python makes these big, ugly verbose things. It's like kind of this line of thing. So the effective user ID, all of this stuff is not available. Subscript separator, AB. This is why people hate Perl, because it's got all these esoteric shell variables that make it look like chicken scratch when you write it, but make it very fast to write. And yeah, I'm not seeing it. OS names, signals. There's all your signals. Base name, Perl version, executable name. They have a different variable for that than $0. $0 has a different meaning completely. Yeah, that's kind of the hard part about doing polyglot, because if I do polyglot, you might get confused. They say it takes you longer to learn like German and Spanish at the same time, but you're better off long term for doing that. There's like the last pattern match variables, etc. Anyway, so I think that's going to wrap it up for today. Let's go back and see how much we actually covered of what we were planning on. I think we covered how to send stuff to the program pretty well. Variables, I'd already kind of touched on it before. Return values was a little bit. The last thing on return values, and I can cover this in 2 minutes. Sometimes you want a string. I'm going to show you how to cheat, and we're going to go out with this. Okay. If you want to cheat, you can, and you can do that by just echoing a value. And I do this all the time. I did this today. And instead of caring about the return value, in this particular case, I just want to see the output, right? So what does that mean? So do you remember when we talked about backticks? So if I type greet here, right, I can do this. I can say echo greet. What will that do? What will that do? It'll replace greet with the output of greet. And then I can say, and something else, right? Now I told you not to use backticks, so you can put the whole thing in quotes, double quotes. You can put this in this, and this is, we talked about this before, so I can go through this fast. And you can see that that spot is replaced with whatever this was. Now I can put a name here. I can put, like Rob or something, and and it will, oh, it's, it's actually using a different program. I have another greet program out there. That's what I was doing. So wait, greet Rob. Did I kill it already? Did I kill my greet program? I did. I'm not calling main anymore. No wonder. All right. So there we go. So there now, well, watch this. This is going to get really weird. You see what it did? It actually replaced with the output there, and you can use that as a return value is what I'm trying to get at. So what does that mean? That means you can use what is printed as a pseudo return value. It's not a true return value. It's a pseudo return value because you can capture the output. So, and you can do this as a command too. So isosec, right? Touch, isosec. So appending to the return value, right? So you can use any of your commands or functions in your code as if they were called as commands. So let me try it. Let me give you another example, and then we'll end up for today. So let's say in main you want to say hi whatever, right? So let's say instead of saying so I could say this. I could say echo here is your greeting, right? And then I could right here I could put I could call hello. And more than that, and watch this magic, I can pass all of the arguments that were sent to me. See that? Okay. So that says, here is your greeting, and it calls hello, throws away the return value, which we don't care about, and takes the output. So the thing I want you to really understand here and not get confused with is the output, which is being printed to standard output, is different than the return value, right? The return value is different than the output. But you can cheat and you can use the output as if it were a return value. And in this case, and the way you do that is you just use this special subshell notation, sub-process notation. When you do this, just keep in mind that every time you do that, it makes a sub-process. All right. And by the way, that's the reason not to make commands aliases, because you can't do that with an alias. An alias can't be called because it doesn't exist. So, but you can even do this in the same code because this is a function. So you can do this. Hello, in this particular case, here is your greeting. Wait, and then we can say echo, on this day, and then we can put the date, right? Here is your greeting. And so we run that, and it'll say, here's your greeting. Hello, Rob Mulestein. All right. So that is the last really main point to make. It's a good one to end on because you really are going to use that a lot. Do not use eval. We haven't used any eval so far. I'm not even going to teach them eval. Bite your tongue. No, we're not using eval. Don't ever use eval. There is no situation in which you need eval. Ever. Ever. You never, ever need to use eval. That's right. Not even when you're trying to source tab completion from Cobra commands. I'm going to talk about that when we do customization. If somebody mentions, so I have to say it. If someone tells you to use eval, tell them to go jump in a lake and they're full of it. And then you should never use it. You never, ever, 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 ever. How many evers is that? I can add another 20. Need to use eval. Eval is how people die. Do not use eval. Okay, I tell you what. Use eval all you want and then call me and tell me where your code is. Please. Please use eval. Yes. Please use eval and then tell all of us where you put your code. Yeah. Tell us all the companies that you work for. I hope you'll use eval. Yes, please do. And then also make sure you don't put double quotes around your variables or anything. Oh no, make sure you don't do any of that. Please don't. and then let me know where you live and work. All right, it's probably time to go. My bash shifts. Go do some rewrites. Dude, you don't need it. You don't need eval. 9 times out of 10, you don't need it. You know what? If you can find a case where you need eval, please bring it to me. All right. You know, this is a lot safer than eval. Now, even this is a little bit unsafe. Some people might say to do it like that, which is exactly the same. Yeah, but it puts quotes around it. Yeah, so you don't need to do it because it's already quoted. So there's no tab expansion. There's no while expansion happening there. So the point I'm trying to make here is that you can use the output of a function or any command as a replacement for a return value where you might have used a string in another language. Okay, but just, yeah, don't go down the eval row. That's it for me. It's been fun. We'll talk tomorrow. I'm gonna turn this off. I'll turn the music right back on, and I will, you know, queue up the videos and send those on their way. And then I'm gonna be hitting the hay. I have to go get my COVID shot tomorrow at 10 a.m. I'm just gonna tell you right now, I may not be able to do this tomorrow, depending on how I take. I mean, I know that the COVID shot is different for everybody, so wish me luck. Tomorrow's at 10, so I'll definitely know by the evening if I'm going to be able to, you know, do anything. We have Monday off though, so I have Monday off of next week, and I don't know what I'm going to do on that day yet. So I will definitely be streaming that night, but I may actually be doing some actual coding and fun streaming during the day. You know, fun coding during the day. So if that interests you, just let me know. Yeah, if I'm not feeling, we'll just skip it. I mean, it's, you know, we're not going anywhere. Give you guys a chance to catch up on stuff. It's been really fun, and I'm going to go ahead and stop. So see you later. Yeah, I don't know we're not doing the Pfizer one, no. We're doing the other good one. Bye.